Hi, and welcome back to another edition of Safety Talks. I had the privilege of speaking with Uncle Bill, and we had an impromptu conversation about masks and quality of air in our workplaces and looking at a new system somebody was sharing with us that could filter in fresh air. We decided at the end we needed to bring in an industry expert, so this is part one of a two-part series. Enjoy the conversation.
Because I think it's important that people are discussing how are we going to be cleaning the air in our environments. And it frustrates me that people aren't talking about this.
I'm with you.
But like when you're working, how would you be thinking about cleaning the air for the workers? Because this is a air droplets is what we need to be concerned about, right?
Yeah, no, totally agree. And that's no one's talking about it, right?
No.
Everyone's saying social distancing and wash your hands and stay at home. And the thing is, when you run down to the bank machine, right? No one is cleaning the bank machine. No one is sanitizing the air around the bank machine, right? Now, if you're suburban, your bank machine is probably just on the side of a building, so maybe the air has a chance to dissipate. But a lot of cities and urban areas, they put the machines inside these little encasements, right, to protect you while you're on the machine. And so nobody's putting giant HVAC systems in there, right? There's no filters, there's no UV. So
Okay, so help me understand this better, because you do firefighting, and so you have some of this background. Is they went around telling us, oh, don't wear a mask, it doesn't do anything because you have to wash your hands and wash the surfaces. And now it's always been, Michael has been always saying from the get-go that it was air droplets because it comes out as you breathe. So he's been on point the whole time. But yet people see this as a conflicting message and going out saying, oh, these people don't know what they're talking about because the WHO and the CDC said wash your hands and clean your surfaces. The scientists now are saying something else.
Well, so there's a couple of things there. One, there's a difference between a surgical mask and an N95 respirator.
Okay, stop you there.
Right?
Can you please explain the difference for people listening?
Sure.
Thanks.
Okay, so an N95 is fit to your face. You have to shave your beard if you're wearing one, and you have a beard, right? Some people don't. And what it's doing is it's officially termed as a respirator because it's filtering inbound. When you inhale, it's filtering, okay? A surgical mask is designed to prevent me from launching spittle into a person who I've cut open.
Okay, I'm going to stop you there.
Yep.
And the reason for that is I just want to back up and really get this. So so the N95 is filtering the air that's coming in. Is that right? Like, so it's for silicone dust and stuff like that.
Exactly.
Okay, so wait,
particulates.
let me continue. Wait, because I don't want to lose it with my disability. So it's okay for the air coming in, but would it be enough for that kind of micro virus level?
So the N95 is actually designed for medical personnel to use.
Okay, I didn't know that, and so thank you.
Not a problem.
So it is appropriate for the filtration of the virus potentially coming in. Now, what about for when you're breathing out? What's the mechanism there?
Well, the filter isn't, it's not a flapper valve. So using my hands, because I like to talk with my hands. So a flapper valve goes like this, right? So air coming this way, it opens, and then air going this way, it stops, right? They call it a flapper valve. So like a big plastic face mask kind of respirator might have flapper valves so that you can exhale but not inhale without going through the filters. Okay? Or things like that. The N95 is a piece of cloth, right? So, here's my N95, and it's going to block the same way in and out. That's why a lot of construction workers, when they don't know to bend the little metal tab at the top, right? When they don't bend that, all of a sudden their eye protection fogs up because they're exhaling and it's going right up through those slots and fogging up their glasses, right? So that's the other thing. The N95, right? It has that cool metal clip so that you can seal it around your face. Okay, so the medical one, all that's doing is preventing me from spitting up little bits of food stuck in my teeth and saliva into a patient that I'm working on, right? Whether it's actual surgery or like in the field as an EMT, sometimes you come across people who have openings that aren't natural, right? And so you put this mask on to help prevent putting germs into them. It's not about preventing me from inhaling anything or smelling anything, right? So, and here's an interesting thing. When you get fit tested for an N95, normally they use like a banana oil or something sweet to test it. You can't smell it because it's blocking those particles.
And that's an important part.
Right.
Because if you're able to smell, then something is getting through your mask.
Exactly. So when you wear a surgical mask, you can still smell everything. Back in 8th grade, my science teacher used to say, when you can smell barnyard, you're actually getting barnyard in your nose. And it's true. I mean, little bits of it, but.
And do you think that generally people understand the concept of actually what happens mechanically when they are breathing and smelling?
We don't explain that to people. When you send someone for N95 fit testing, then they get a little piece of paper that they sign. Normally it's a piece of paper because that protects the liability of the people doing the fit testing, that explains to them about smells and why it's important, right? If you can smell stuff, that means your N95 isn't on correctly, isn't fitted correctly, isn't attached correctly. But other than that, no one ever explains that, right? So you go out in town to go get your groceries or to stop at the hardware store or stop at the bank, and you see people wearing N95 masks with one rubber band around their head and the other rubber band hanging loose, right? So that's now ineffective. It's not doing anything. It doesn't protect you on the outside or me on the inside.
Now, do you think they were right when they said to us wearing a mask won't help us at all? Like, because the doctors and the nurses are wearing masks. So if it doesn't help us at all.
Here's the thing. An N95 mask should help you. A surgical type mask will do very little, if anything. Does that make sense? So
yeah, it does. Let me go get the one that I bought for
Sure.
this discussion. Just a second.
Now
Hold
that
on a
one that
minute.
you,
So
yep,
this mask, I just want to put it in context for people, right? Is we were painting our house.
right?
Okay. And I don't like the smell of paint fumes and stuff. So I bought this in order to wear this for paint fumes.
Okay, now does that actually block paint fumes?
Yeah, it does pretty much. I mean, it cut it down. I was
Okay,
happy with the product.
does it have a tag in there that lists like an ANSI standard or something that it
No,
follows?
it's not that fancy. No,
Oh,
no,
okay.
no, no. It
Um,
was just for home, eh?
no, understand.
It was
The
just something that we had found, and so I tried it out, and it's like, oh, this is working for me. Some guy was smoking a vape, and
yeah,
it cut down the smell of the vape, and I was like, well, it's not 100% perfect, but
but it's doing something.
it's doing something,
Yeah.
right?
So you see how it has the little loops that go behind your ears?
Yeah, just a second.
Oh, no, you don't have to
Let's
put it
get
on.
interactive here, Bill.
Yes.
All right. These here.
So as a general rule, masks that attach like that, where they go behind the ears, they're not going to make as good a seal. Now, it looks like you've got just a little bit of gap up
Yeah,
here at your nose,
I
right?
do.
Because there's no little closure there.
That's right.
So it's not something I'd want to wear uh, into a place where they're making, poison gas,
No, no,
right?
no.
Um,
And it's not going to help with the virus,
right. That's all I was trying
right?
to
Because I
say.
still
Was,
got holes here. I can
right.
look at. I can snip my fingers. This is not a mask
Right.
for protection. Like this, as I said, it was just more or less to stop having the fumes of the paint go in my mouth,
Right.
and it worked. We were happy.
Awesome.
And so you don't have an example of the N95, do you?
No, I don't. I'm sorry. I had some, but I donated them. Now, here's the thing. You know how all the hospitals are asking for people to donate? They only want unopened packages.
Why were people sending open packages?
Well, no. So if you buy a package of 10 and it's all sealed up, right? There's a plastic bag inside
Mhm.
that, keeps it safe. Once you take an N95 and it's out of the plastic and it's not on your face, it's no longer going to protect you because the side that goes to your face is now open to the ambient air and can collect anything.
Yeah, that's right. It's contaminated.
Right. So a lot of times you'll see people when they're done with their mask, they stick it in their pocket, right? Which isn't bad, or they hang it around their neck, which is
Right.
bad.
Why is that bad? Can you explain that?
Okay, so if I pull it down, right, so that both straps are around my neck and it's just hanging out below my chin here, it's open on the back side to ambient air. And so
Right.
any contaminants that I'm using the mask to protect myself from are now able to get to the inside of the mask. And since I've been wearing it, it's all moist, which
Right.
means they're going to stick, right? So it's like, you remember the little game where you have all these metal shavings and you use the magnet, right, to make hair for the guy and a beard and stuff?
Yeah.
So it's the same thing, right? All the icky stuff is sticking to it. And then I'm going to go and eat lunch and do this and do that. And then I walk back into my contaminated area, right? And then I say, oh, I should put my mask on, right? Because the same kind of people that are going to wear it around their neck aren't going to put it on correctly before they enter the area.
And so, when that makes me think of like when I'm seeing people who are working construction and they're wearing it for protection of construction dust.
Right?
Um, how are they supposed to be actually cleaning the mask?
You can't clean an N95.
So
Once,
you have to throw it out.
yes.
I don't think
And
people understand that, because I'll go by and I'll see somebody wearing something that you can tell they've been wearing it for days.
right. So here's a fun little trick I learned. When you issue out N95s to people, one, you don't want that box sitting there open to ambient air, right? Two, you want people to have a place they can properly store their N95, right? Because when I hand it to you, you're not going to put it on. You're going to go to your work area. And three, when it's time to dispose of the N95, you want to be able to dispose of it properly. So you
So
can
what is
issue,
properly?
well, I want you to think about this for a second. Once you've worn an N95, doesn't that have a whole mess of biological waste on it?
One would think after breathing in there, like
Yes.
you can smell that, like even when I was painting,
Right.
after about 20, 30 minutes, you could actually smell my own breath in there
Right.
a little bit. So that tells me it's still capturing stuff.
Right. So, like in the medical world, an N95 has to go in the biohazard bin. Okay. So what you can do is when you issue the N95, you can issue it in a Ziploc bag. Right. So before you go and issue them, you can take them out of the package, put them into a Ziploc bag, and preferably do this somewhere clean, right? That's not filled with contamination. And then you issue the worker or the employee or person or whatever you want to call this individual an N95 in a Ziploc baggie.
Right, right.
Right. And the last place I worked, what I did was I bought a gross of freezer Ziploc baggies that were quart size, and so there was a place people could write on them, and so they could write their name or they could write whatever they wanted, so they'd know it was theirs.
Right.
Okay. And then you can carry it around with you, and then if you need it, you open it up, you put it on, bingo, bango, boom, and it's clean. It hasn't been sitting in your pocket for 3 weeks, right? You haven't run it through the washing machine, or if you have, it was in the Ziploc bag, so it's okay.
So that's a little bit about masks and the difference between a surgical mask and an N95 and what is it
Right.
used for? What's it not good for? The store-bought ones that a guy showed people, that's not going to help you in this situation.
Right.
You know, and so that, and if you are using the mask, you need to be providing it to people in a way it's not going to get contaminated before they even put it on their face. And I love that Ziploc bag example that you gave us. So now I want to kind of move into more of our open environments where
Right.
we're working in offices, we're working in manufacturing plants. We're not going to be wearing masks in this environment, but do you think air quality control is still important?
Well, of course it is.
Oh, okay. Because not a lot of people tend to think that way, obviously, with all the pollution and stuff that we're being allowed to breathe in.
Well, everything is relative, right? So if you go to Shanghai, China, the air quality is, I'm going to say, less than Toronto, Canada, right? But there are still people who live in Toronto who, when they go outside, they get shortness of breath, or they have asthma or bronchial symptoms, or they they have various troubles. So they have to have medical interventions, right? Like a rescue inhaler or one of these non-rescue inhalers, right? The one they're always advertising on TV. So even in Toronto, there's things in the air that can harm people, right? Some people, and in certain amounts, right? So I don't want to scare everybody that, you know, we all have to walk around in containment suits for the rest of our lives.
So what I want to get into here with you is it's very important that as health and safety professionals, we consider what is the air quality that our workers are working in. Because I have noticed that when the air quality is poor, people tend to get tired, get headaches, and this is really disruptive to the flow of productivity.
Well, and it's also, it can be disruptive to their health, right? And so there's costs associated with that also, not just monetary, but also if people don't feel well working for you, who's going to want to work for you?
Right. Right. And so what way can professionals be looking at assessing whether or not they need to be concerned, first of all, about the air quality in the workplaces that they're faced with?
Okay, so it's a multifaceted plan, right? The first thing is, do you have chemicals or substances that are harmful, right? So according to your MSD, right, because we don't call them MSDSs anymore for some reason, do you have anything that can create an atmosphere that is physically hazardous or known to be physically hazardous, right? So that's step one. You've got to understand what substances are possible, right, to contribute to poor air quality. But aside from icky solvents and things like that that can do real damage to you, there's other problems in air, right? There can be smells, there can be fungus, there can be bacteria, there can be viruses, stuff like that, right? So some of this stuff is relatively easy to measure for, right? So if I want to measure CO2, I can get a gas meter, right? If I want to measure flammable or explosive fuels, again, the gas meter. If I want to measure for the common cold, I don't know of anything that does that, right? So I can't validate my environment just by testing the air. What I can do is I can tell all my workers, hey, if you're sick, don't come to work.
But now, when we naturally breathe,
yeah,
and we are exhaling and breathing in, I have noticed that in workplaces, over the period of the day, it can become more stuffy with people breathing in and out. And so that concerns me because, you know, I don't come to work sick. I choose to try to stay home. And then somebody else comes to work with just a cough or something. And then what we find is then it kind of spreads. And so how can we be, like, we really, as health and safety professionals, is that not part of our purview that we should also be thinking about how can we cut down on opportunities for this, not just chemicals?
Well, I guess when I say we go through the chemicals and substances first, what I'm alluding to is the fact that these are known things that can be measured and understood, right? As opposed to, from my standpoint, a virus or a fungus. Well, funguses you can actually measure for fairly easily. So a virus or a bacteria that I might not be able to easily measure for, and I just have to take into account that they may or may not exist at different times in the air, right?
But if I'm thinking back and, and doing my checks in October so that I know that flu season is coming in Canada. Back in September, October, I know that November, December, January, flu season is coming. So you start preparing for that in my mind.
Well, so it's going to depend on your environment, right? So if you're in a building, then you can have an HVAC system that has filtration, right? They've got UV filters in there, they've got physical filters that can clean that stuff out, and you can move a certain number of cubic feet per minute for each employee, right? So if you know I'm going to have 700 employees in this building, then you can do math and say, okay, I need to move X cubic feet per minute, right? And I can go and I can measure that, right? As soon as I work outdoors, right, like say construction, I no longer have that ability, right? Now I can seal up an area and make ventilation in that area, right? So if I'm dealing with something that can be measured, so I can say, oh, I need to move more air, or I'm moving enough air, right? The problem is, since I can't measure the virus or a bacteria, I don't know if it's present or not.
So going back to the construction thing,
right?
For a minute, I want to stay on that for 1 minute, because there is actually fans and filters that you can be purchasing in order to help reduce the dust
right
on your sites. There are methods to take that and those are that particle dust pieces that they're looking at.
Right, but you want to, rather than remove the dust, you want to not create the dust.
I would think that elimination would be key, because that's what we're supposed to be doing. If we look at our hierarchy controls,
right,
elimination is the first thing.
Right. So you'll see that a lot of times people are using water when they're creating dust, right, to keep it too heavy to fly around. Okay. The other thing is you can use materials that have like sandpaper or whatever that's attached to vacuums, right? So you're creating the dust, but you're either treating it so it stops being dust, or you're sucking it up. Positive ventilation, right? Positive pressure ventilation should be your last option, because then what you're saying is, we're going to let it all hang out in this area and prevent it from going into other areas.
And that's what I really wanted to get you to go to, is that first you should be really looking at those measures to totally eliminate it, so it's not even there.
Right.
Now that's an outdoor construction environment. So what can we be doing on the inside? Like when you're going to a grocery shopping place to shop, and there's a lot of people that are getting in there, or you're working in an office, you're working in a plant. These are more inside environments. And now you talked about chemicals, but there's more to the filtration than just the chemicals that we need to start thinking about, if we haven't already.
The problem, as I see it, and I'm not an expert on this, Michael sounds like he's more of an expert, but the problem I'm seeing is, in order to do the calculations, you have to understand how many parts per million, right? So if I need to know how much positive or negative pressure I need to put into an environment, I have to understand what I'm trying to control. And the thing is, at 2 o'clock in the morning, if you go down to your local grocery store, there might be 7 people in there. And at 8 o'clock in the morning before a Sunday football game, there might be 700, right? So you've got different uh, quantities of people in the same amount of space. And then with those different quantities of people, some people may be exhaling things or off-gassing things that are harmful or offensive or whatever, and other people may not. And so on one day, you may have 7 parts per million of all these various combined things. And on the next day, you may have 100 parts per million of all these various combined things. So how do you control that?
I would think then, is that where maybe smart technology can come into play?
It is possible, but I think it would have to be really, really smart technology, right? Which means we have to have really, really smart people designing the technology. When we do the calculations for an office building or a lab, right? So let's say you have a negative pressure lab in your building that's filled with labs. When you create that negative pressure, what you're saying is, it's okay if outside air comes in, but I don't want any air from here going out, right? So that's a way to control what's inside that room and prevent it from leaving that environment where you have people that have a certain protection level inside there, right?
And so when I was talking to Michael, what he was explaining to me is that you could have a system
Yeah.
where people are standing, you would have a draft coming downward and something sucking it out in order to create a movement of air where people are standing. What are your thoughts on that?
Well, you could. I think there's a lot more math in it than you or I are talking about right now, right? Because we need to know how big that person is, right? Not just that there's a person there, right? Because how much air they're taking in and putting out is going to affect how much air I have to move, right? You know, I'm a little bigger than you, so I might move more air than you do. So how do we make it so when I'm standing there, it moves enough air for me, and when you're standing there, it's not blowing your hair around. So it's kind of, I haven't looked into that enough to understand that enough, right? So like the M1 tank has a positive ventilation system. So the air is physically leaking out all the seams where it can, all the little joints. And that prevents icky stuff from getting inside the tank, right? So biological, chemical, nuclear things, agents, what have you, don't get into the tank because the tank has a higher pressure than the ambient outside pressure. But again, it's a small contained space. We know exactly how many people are there, and we can average based on an average size because we know there's not going to be any children in there, right? We know there's not going to be anybody 8 feet tall in there because you don't fit. Okay. We can't do that in the grocery store as easily, right? With an office building or a lab, we know what the approximate number of people in that space is going to be, right? Or we have a maximum and a minimum. And we can even program the system so that at 5 o'clock, you know, it becomes a lower pressure system, right? The HVAC systems are very, very good at stuff like that.
Well, let me show you a picture of
Sure.
what I was showing with it's called a blue sky system. And let me get your opinion on this. Can you see my screen?
Yes.
What are you
Ooh,
seeing?
that's neat.
That is neat, eh?
Yeah.
So this is, remember when we were in that session and Michael was trying to talk about the airflow and everything? You remember that guy?
Yeah.
Yeah. Okay. So this was actually what Michael was going on about. And I was hoping he could join us today, but I think he got busy. Tell me your
No,
perspective on what you're seeing.
well, so the little arrows are telling us, where air is getting sucked in and where air is getting blown out, right? And it's giving us basic directions, but it doesn't give us any numbers. So, just from this picture, I can say, boy, that looks effective, but somebody had to do the math to make sure it was effective. You know what I mean?
So share with me more what your questions would be around this.
Well, just like when you design a bridge, right? You have an engineer who's licensed and understands, right? So they're educated, they're knowledgeable, they're experienced, and they're licensed, and they stamp the drawings, right? So I'm going to go on an assumption here that I would want someone who has quantifiable knowledge and experience to design this system for me and say that they believe it will work for these reasons and explain it out to me, right? So my assumption is where these little blue arrows are coming down, right? That's air being thrown into the environment. So we need to move a certain number of cubic feet per minute into that environment based on its size, based on its expected occupancy, and based on what we expect to be there. Likewise, these lavender arrows are showing us where air is getting sucked in. And again, we can measure that in a volume, cubic feet per minute. How much am I sucking out? Now, I'm pretty sure I want to input and suck out the same amount, but that's a guess. I'm not an airflow expert.
Yeah, no, I'm not an airflow expert either. So that would be hard for me to answer. Well, my understanding when he was explaining it to me was that you see where the air is coming down? That would be very light air drafting down in order to push things that we're breathing out or other contaminants in the airflow down into the filtration system.
Right. So long as they were as heavy as or heavier than the ambient atmosphere.
Okay. So what you're saying is that the more people that get in here, the heavier the ambient atmosphere? Or no, am I wrong?
No. So
Help me
helium,
understand better then.
well, helium weighs less than air, right? Than the air we breathe. So it rises. Mustard gas weighs more than the air we breathe, so it sinks. Okay, so I can have all this air pushing things in different places, but if I were to release helium into that room, it's going to go up. Does that make sense?
Okay, yep.
Right? Now, helium is not, it's not horrible, right? Everybody has taken a helium balloon and untied it and sucked in the air and started talking like this, right? Well, if if you actually suck in too much helium, you will pass out,
Right.
right? Because it's displacing oxygen and all the other, nitrogen and things like that are in the air that we breathe.
Right.
Okay. Now, let's say we're using hydrogen, right? So hydrogen is lighter than air. And it's sort of dangerous, isn't it? Right? It's explosive.
Mm-hmm.
So
What does an air conditioner or normal air filtration system use, Bill?
what do you mean?
Well, we do filter in stores and environments right now, so let's stick with what it's doing.
Well, I think you have inputs and outputs throughout an environment, right?
Right. Yeah.
So air returns are the outputs, and the inputs are uh, airflow grates. I don't know what you call that. And then the air circulates, right? Because it's being physically moved, right, with fans. And then you have filters, right? So the kinds of filters, there's mechanical filters, right, where you actually change that cardboard thing like you might have at home, right? So you get this cardboard square that has all this filter hair paper in there, right? And it's kind of corrugated, and you change that out twice a year in your home HVAC system, right?
Yeah.
But there's also people use UV lights. People use substances, I think, where they're physically spraying things into the air. I don't know all that stuff. I'm not an HVAC expert, but there's all kinds of different filters that people do use.
Mm-hmm. So here is the system on the outside. So remember those blue and purple
Right.
zones?
Yep.
So now you've got the clean air going in, and the purple is the air going out.
Okay.
And then what happens is that the filtered air coming out actually goes into what they call a smart box.
Right.
So they just take the whole box. So the workers, nobody has to touch that air filter anymore.
Huh.
Yeah.
Well, so once the air is filtered,
Right.
how does it leave the system?
So if remember that other picture that I showed you? Okay, so the blue air goes into the place.
Right. So that's ambient air.
And you can see this one now?
Right. And so the blue air comes in from the top. The blue air going into the building, right?
Yeah. That's right.
The pickup for that is in the driveway for the drive-through.
Here it is, yeah.
So are we filtering that to get the CO2 and other icky stuff out of there?
I would think so. I would hope so, yeah. I think this would have to, you're right, this has to be positioned in a place that it's drawing in clean air.
Right. Or we have to filter it. It looks like, if you look at the front of those boxes, it looks like there's kind of handles for opening them. So maybe that's so that the filters can be changed.
Yeah. Okay, so I'm thinking, I see your point about the drive-through. That kind of came across my mind too.
Yeah.
Right? And so this here would have to be positioned somewhere else where you're not having CO2s come by, definitely.
Well, but Michael may have filters in there.
Yeah.
Okay. Also, wherever the air pickup is, right? All these things we don't know.
And that concludes my conversation with Uncle Bill. And we hope that you enjoyed our conversation. We went over a lot of different things, but we have a follow-up to this series where we are going to be joined by Michael Seitz, and he's going to walk us through his air filtration system. So that's very interesting. That's coming up next week. And if you are looking for other places to network with people and get some great safety ideas and knowledge, join us for our Safety Connect, our first online e-conference happening October 2020. It's free to register. Go to industryconnectsafety.com. If you're looking for more safety information or the notes for this discussion, go to safeopedia.com. You can find a lot of webinars, Q&As, and articles about safety to share out with your team and your network, as well as under podcasts, the notes for this episode. Until next time, stay safe.